So we'll get things kicked off here. This presentation is really geared towards either existing PowerMill users that are looking to see what has been added recently, or if you don't have PowerMill, you can see some of the more advanced features that are capable within PowerMill. So these are really just the release highlights from 2022, the first release. Since then, Autodesk just this month released another update to 2022. So there's even more features than I'm showing you today, but these are the ones that were initially released when the product was launched for this year. So we'll go through some of those highlights here. So they've added some changes to the way that PowerMill calculates flats. So if you're doing any flat machining, this is when you have like a mold or a part where you have a pretty complex design with a lot of different surfaces, but you just want to clear up and clean up all of the flats first before you finish the rest of the curved and projected surfaces. It can be a really efficient way to get that material off of those flat surfaces. So Autodesk has improved the way that you can eliminate those if you want to focus on just the curved surfaces. So there's a new feature where you can just exclude flats from your steep and shallow toolpath. That can be used on several finishing toolpaths, but the most ideal scenario is when you're doing steep and shallow finishing. So instead of doing any of these shallow surfaces that are flat, it'll do up to surfaces that have an angle to them, but if they are perfectly perpendicular to the tool, they will be excluded from that toolpath automatically. This is really helpful because you don't have to go through and figure out an angle range or a limit with too much detail. You can just really quickly exclude those. They've updated the way that flat machining calculates corners. So there's some improvement into the corner finishing of flat surfaces that have been added in as well. Constant Z with undercuts. So they've added in the ability to use the constant Z finishing toolpath with undercuts when you're working in 5 axes. There's been improvements to the spiral version of that as well. 4-axis collision avoidance. This is something that is really helpful if you do a lot of rotary operations. So if you have a 3-axis mill and you have a rotary table attached to it or some type of setup with a rotary, what this allows you to do is not only create that toolpath, but also avoid collisions. The prior releases didn't have collision avoidance when working in 4-axis like that. It still had collision avoidance for 5-axis toolpaths, but these rotary toolpaths, it had trouble calculating those collisions, so they've improved that. Projection ranges, they've added in the ability to control the range that you're using when you're working in 4 and 5 axes. This helps you to eliminate having to create a lot of boundary curves and surfaces. And then staggered start points is a really useful tool when you're working using the side of your tool specifically. So if you're doing a lot of 5-axis swarf machining where you're working down a sidewall, you can now stagger the start points so that eliminates marks on the part. So we'll go through these in a little more detail here. Finishing that excludes flats, you'll see on the right there, they show a toolpath where it's basically finishing out the entire surface of the part using a steep and shallow toolpath. This same process can be applied to raster toolpaths, which is a constant angle finishing, or 3D offset finishing, which is more like a scallop, if you're familiar with Inventor HS7 Fusion 360. So what you can do is essentially just exclude anything that is flat and perpendicular to the tool, and it does it automatically without the need for any limits or surfaces. So you get a lot of improvement in the quality of your toolpath. It's going to be faster to program the CAM operations because you can just separate those toolpaths out and have a little bit more control over the process. The cycle time should be faster running it in this manner as well. There's fewer retracts and lead-ins and lead-outs because it can eliminate those flat surfaces entirely and focus on the curved ones. It will blend the toolpath together a little bit more efficiently, and you're going to get a better cutting tool utilization. So you'll really be able to run that flat end mill at probably a higher feed rate. Same goes with bull nose or tip radius mills. You can clear off those flats pretty quickly using this method. So for flat machining, they've made some improvements into the way that these boundaries are calculated. The biggest improvements have been to internal corners. So I'm going to show you this on a live part as well. But what you'll see is the older versions of PowerMill have a little bit of trouble calculating the transition of the tool through a flat internal corner. It would typically add a small radius or a straight line to it, and it wouldn't quite get all the way into that tight corner, which would make it a little bit more difficult when you're going to finish those corners later. They've added in some improvements into the way that that transition is made. So it'll be a sharper corner, especially on those internal corners. So you should get a better surface finish and a more consistent surface finish through those corners. You won't really need any manual polishing or rework. So when the part comes off the machine, it should be done and within tolerance. Constant Z with undercuts. This is a really neat one. You can see from PowerMill 2021 even, it still had a little bit of trouble calculating the constant Z toolpath when you had a 5-axis undercut. So if you were orienting the tool at a significant angle coming underneath that surface, as soon as you started that undercut, you'd either get a toolpath that was very fragmented, so there was a lot of lead-ins and lead-outs and repositions of the tool in that radial direction, or you would get a non-continuous toolpath with a lot of segments and redirects to it. So this overall, the machine motion is going to be a lot smoother, which is obviously beneficial for the surface finish of the part coming off the machine. And this has been added into spiral and non-spiral options. So if you're just working your way down in a circular fashion, so one pass at a time, it can be added to that. You can also add this setting into a spiral constant Z, where the tool is engaged more and it's spiraling down the surface as opposed to just making consecutive circles. So in general, it's going to be a much smoother motion on the machine, which is more predictable. Typically, it's going to be a safer toolpath to run, and you should get a really nice finish coming off. The rotary, so this 4-axis rotary collision avoidance now is available. So you'll get a safer toolpath. You'll notice in the older versions, sometimes on more complex rotary parts, if you had a tight internal corner like they show here, and the tool didn't have enough length, you would get a collision with the shank or the holder coming around that corner. What they've done now is the tool will remain in at an angled position through that corner to achieve clearance before continuing through the rest of the toolpath. So you'll get a toolpath that machines that surface with more accuracy, but it will also be a safer toolpath that's not going to collide on these more complex rotary parts. So much more easier to predict this machine motion, kind of like with the undercut scenario. You know what the tool is going to do, and you know that it's going to be safe when you go to run it on the machine. So protect your machine, protect your fixtures. Those are all really good things. Projection ranges. So there's a new user interface here that allows you to achieve a little bit more control over the way that you create curve and surface projection toolpaths. So this is typically scenarios where you're going to be working in 5 axes on more complex components. This allows you to either automatically manage this, or with a manual setting, you can enter a minimum and maximum projection range. What this does is it limits the toolpath to the surface of the part, and it eliminates the issue where occasionally with projection toolpaths, it would project to the side or the fixture geometry as well. And so you get this wild toolpath they show here on the left, where when it's trying to automatically calculate this boundary, it typically would leave some fragments, or you'd get a complete implosion like they show here. And so using that manual range allows you to just say, you know, I'm only going to go down to a -5 millimeter and up to a max of 10 millimeters for that range. So in general, what this does is it just prevents you from needing to create this with either a different toolpath or create a lot of limitations with your boundaries to get this to work properly. So you'll spend less time programming and then more time machining, which is also always a good thing. All right. Staggered start points. This is typically when you're working with a swarf operation. If you're using the side of the tool or the side of your flute here, this is going to allow you to improve the machine motion along that sidewall. So it'll eliminate the issue where if you had the start point default, where it's going to be basically starting each subsequent Z pass in the same location. The problem with that is sometimes you'll get marks along that line because you're starting the toolpath in the same spot. The advantage of a staggered start point is that the subsequent passes will actually clean up the feed-in mark that was left from the previous pass because it will be engaged along that sidewall. So each pass as you go cleans up the previous one. So you'll end up with a really nice continuous surface along that wall, even on more complex angled surfaces that you're swarfing. So this is most ideal when you're using the side of the tool. It can keep that motion forward, keep the tool engaged consistently, and so you won't get those dwell marks or those feed-in marks on the sidewalls. So less work to do when it comes off the machine. You don't have to do any polishing. Should be a nice clean surface to work with. So that's it. Those are the primary improvements. I'm going to show you these with PowerMill here in a second. Just keep in mind these are kind of the biggest features in the new release, aside from just general speed improvements. So they have increased the speed calculation times for all of the toolpaths in PowerMill, especially the roughing and finishing operations. So those 6 improvements have been made, and then in addition to that, there's a much faster calculation time. The projects will save more incrementally now, so you'll get a you won't have the issue where maybe you miss out on some work that you did because it didn't save. So you'll have more incremental saving. In general, though, the speed every single release of PowerMill has been improved. So when you go to calculate these toolpaths, it should save you a lot of time, even on really large parts and large molds that you're working with. So if you want more information about the release, that Autodesk page for PowerMill 2022, they have all of these highlights in there if you want to learn more about any of those, but I will be showing you a few of those toolpaths right here. So we'll jump into a technical demo. So if you have any questions that come up, start thinking of them now. After the demo, we'll go through the Q&A. So let's get into PowerMill here. I've got a lot of projects open to show you all these different scenarios. We'll start with the flat machining option. So what this is a part that was finished using a steep and shallow toolpath. So steep and shallow, the way that works is anywhere you have a shallow surface, so something that's typically 30 degrees or less off of the perpendicular axis. So you can see this surface would be considered a flat surface. What it will do is use a offset toolpath, a 3D offset toolpath, to use a constant step over, machining along those flat areas. When you get to a steep area, what steep and shallow does along these sidewalls is use a constant Z step down toolpath. So it combines 2 toolpaths together to create a really nice surface. Now, the issue with this is maybe you are going to use a separate tool. So maybe I want to use a flat end mill to machine the flats. Right now I have a ball nose selected. So rather than try to limit the toolpath to the curved regions by creating a boundary, I can save myself some time by just activating this new tool. You'll notice in PowerMill 2022, there's now the option to exclude flats. And so when you are setting up this toolpath, you'll notice steep and shallow gives you the ability to choose which toolpath and which step down or step over to use for each of those. And then when you're setting up the actual settings within this toolpath, there's also the ability to control things like your tool that you're using, and then you can exclude flats here on this limit tab. So in the limit tab, this is where you can set a boundary. But if you know that your boundary is essentially just eliminating all flat, you can check the box here where it says exclude flat, and that will eliminate that from the toolpath. So this toolpath here has exclude flats turned on. So you'll notice if I compare them side by side, so here's the original, here's the new improved version, and you can see that it automatically excluded all flat surfaces, and it still has the toolpath on all of the original curved surfaces automatically. So I don't need any limits. All I have to do is check a box, and I get a really good toolpath that's perfectly limited to those steeper surfaces. All right, let's look at another option here. This is the staggered start points. So this is the original toolpath here, and you can see the tool when it gets to this section here. This is where it's leading in each time. So each time as it comes around that bottom surface, it's leading in at the same location. Let me zoom out and show you what this looks like with the toolpath of running. So let's go ahead and simulate that toolpath. So this is going to have the original toolpath where you do not have staggered links. So when it gets to that section where it needs to lead in, right in there, you'll notice it stops and it leads back in. And then as it comes around this time, I'll slow it down a little bit, it leads into the same spot. So each time the tool has to restart, it's leading in onto that same face at that same location. So that can leave some marks on your part. So the new option in here in 2022 is the ability to stagger these. So this is controlled on the leads and links options in your Swarf finishing toolpath. You'll see you can specify how you want to lead in and lead out, but you can also now, if I click recycle here, calculate this stagger start points. So this checkbox, when you activate that, it will automatically stagger those. So the toolpath will look like this. And notice that the toolpath is the same, but the lead-ins and lead-outs right here are staggered. So it's choosing a new location and staggering that entrance point along that surface each time. So if we simulate this, so I'll go and I'll do the staggered links this time. You'll notice when it gets to that section where it needs to lead in, it staggers that entrance point. So right here, it moves it over. Next time around, moves it over again, and then moves it over again for the final pass along the bottom. So those orange lines there are the lead-ins, and you can see it moves it over each time. And so each subsequent pass will clear up the surface mark left by the previous one. So we'll get a really nice finish along that wall. So that's the Swarf finishing toolpath with a staggered link activated. How about your constant Z undercut? So this would be a 5-axis scenario where I want to machine this surface in one go. So I have a scenario where as I come around this corner, it's going to be an undercut surface that I need to machine with my ball nose cutter here. So in the original 2021 here, what you'll get is a toolpath that can't, in this case, this is just the standard Z, constant Z toolpath. It can't quite machine all the way down on those undercuts. Let me slow this down and move it over. What you'll get is a toolpath that's very fragmented, and so it has trouble calculating exactly where that tool position is. So here it's actually not quite on the correct surface. When it gets to the bottom here, it's going to adjust the tool axis again to finish that out. So this would be your constant Z undercut, the original one. You can see it doesn't finish out that full surface there, and it's pretty fragmented. If you look at the 2021 version of the constant Z with a spiral, it's really fragmented on that surface, so it's trying to maintain a constant spiral cut on that surface, and you can see that it's looks a little bit like spaghetti in there. So got a lot of tool axis repositions, and it's trying to re-engage the surface and maintain that spiral. So if we look at that one, this is going to be our undercut spiral here. Looks pretty good to start, and when you start getting down into where it needs to undercut, you'll notice things start to get a little bit hectic. So it's asking me to reconfigure here, so it's reconfiguring the tool axis. And now I'll simulate it again. And it's difficult to, I mean, even here when I'm just trying to simulate it with the machine, it's difficult to predict where that machine is going to go next. So go back to an ISO view. The tool axis is changing all the time, so you're getting a really difficult simulation here. So it's going to move all over to the side here, and then it's repositioning again. And you can see there's a lot of motion. So you can see how much the table is moving and how much that head is moving back and forth and repositioning all the way around. And the tool path with all the lead in and lead outs just looks a little bit crazy too. So a lot of motion, a lot of unnecessary machine motion that can lead to a poor surface finish on that undercut area specifically. So we've got a scenario where with the standard undercut turned on, it doesn't fully calculate the tool path. So it doesn't get that internal surface there, the undercut surface. And then with the spiral, it's a little bit crazy. So what you can do instead now with 2022 is you can go into your settings. And what it'll do is the way that it calculates, there's not really anything else you need to activate. They've made improvements to the way that it actually limits that surface. And so you'll get a toolpath for a standard undercut that's very consistent. You can see it staggered the lead-in points all the way along. And also you get a really nice consistent toolpath, and it's going to pick up the full surface. For the spiral toolpath, you'll notice it maintains the tool engagement throughout the entire thing, so there's not as many lead-ins and lead-outs as you would get with the standard undercut. And it's going to be a really nice, smooth toolpath. So let's take a look at that spiral toolpath, because that's probably the smoothest one you can run here. It's really a beautiful toolpath that's created. So as it goes around the surface, it's going to look exactly the same. But you'll notice when it gets to that undercut region, it's very smooth in the way that it engages the part. So right when it gets to this fillet here, it's going to start to use all 5 axes. So it's going to ask for a reposition here. So we'll reposition. And then now what you'll see is, as it goes around, it's very smooth, and you'll see it's a consistent rotation. The tool is engaged at almost the same angle the whole way around, and it's using the table to rotate that part a full 360 degrees. So it's really smooth. You don't have as many unnecessary movements in the table, and the tool axis is almost the same throughout the entire cut. So super smooth, spirals all the way through that undercut, and then continues on down through the flat surface at the bottom. So again, that's not really a setting that you need to go turn on like the other things that I've shown so far. With this is just an improvement to the actual calculation of the toolpath. So no settings to activate there. So let's take a look at this rotary. So this would be a 4-axis toolpath where you're indexing the part with a rotary, and you need to make sure that you have a safe toolpath to work with. So here's our rotary toolpath. You can see the tool coming in from the side here, and it's going to be indexing about that x-axis. So this shown right here, this is the original 2021 toolpath. You'll see it looks pretty good, you know, to the naked eye, but when you go to simulate this, what will happen is you'll get a collision because there's no collision avoidance in this for this rotary toolpath specifically. So I can go ahead and run it as is. What you'll notice is it doesn't say there's a collision, so there's no warning or anything, because it doesn't have the ability to check for that in the rotary scenario. So you'll notice as it comes around this corner, it runs the spindle right into the side of the part. And there's no warnings that come up in PowerMill because it has not detected a collision in that 4-axis scenario. In 3-axis and 5-axis milling toolpath, it's able to do that, but this rotary toolpath specifically did not have collision avoidance. You'll see it just keeps slamming into the part. So that's going to cause some damage to the tool. That's probably going to break something on your machine. So it's best to have it avoid that at all costs here. So the new toolpath, there's an option in here for rotary that they've added in. On the machine axis control, you can allow it to use any orientation that you want. And then for the tool axis, you have the ability here to turn on automatic collision avoidance. This was not something you could do with rotary in the prior releases. So it's automatically going to adjust the toolpath to avoid a collision. You'll notice the toolpath looks a little different. You'll see how it kind of tapers out. So it's going to adjust the tool axis slightly to avoid that collision and then continue on machining that surface. So with the new version for 2022, it's going to come around, and when it gets to that tight corner, notice the tool is going to adjust the position and avoid that collision. So right at the last second there, it's going to rotate outwards to avoid the collision and then go around the corner. Just like that, before it hits the holder, it will go ahead and index the tool around. So some safety improvements here. If you do a lot of rotary 4-axis work, this is going to save you time trying to come back in with a different tool or use a longer flute length. You can use a stubbier, shorter tool and still get the same quality of toolpath with that collision avoidance. So something that PowerMill users are probably familiar with from 3-axis and 5-axis milling toolpaths. It's just been added into the rotary function of PowerMill 2022. All right, last one I wanted to get into here is going to be our improvements to flat machining. So with flat machining, like I showed earlier, you can now exclude flats from steep and shallow. One of the other improvements that they've made in PowerMill 2022 is the way that the flat machining toolpaths are calculated is more accurate. So you can improve it on both fronts basically. So with this machine here, what we're doing is machining just the flat surfaces on this part. So anything that is perpendicular to the tool axis. So in the original 2021 version here, you have to really look closely to see the improvements here on this one. So I'll guide you through it. This flat section here is an internal corner, right? So we're coming in with the tool and we're coming into that tight corner and machining as much of that flat surface as possible with this tool. You'll notice when it gets to the corner, it doesn't keep that sharp corner shape. It doesn't match the surface shape. It kind of squares it off. So you'll either get it rounded off or square it off like that. In the new version of 2022, you'll notice it matches the surface corner perfectly. So it goes into that tight corner and then sweeps back out. So if you lay them over each other, you'll see the white one is from 2021, the green one is from 2022. You can see how it came around that corner with a tighter tolerance, and so you'll get a better finish into these tight, flat corners. So we'll go ahead and simulate this one. So I'll simulate the new version from 2022. You'll notice it does it on any of those internal corners that you have. It's going to maintain that nice tight radius. So on all internal corners, it's going to give you a better finish, more accuracy. You're not going to need to use as many corner finishing toolpaths to improve that. You can do the whole thing with one tool, and you're not worried about leaving a small amount of stock in that corner and having to polish it later. So you'll get a much more accurate toolpath. So just keep in mind, they've made several improvements to flats, either excluding them from other toolpaths or within a flat machining toolpath, improving that accuracy. All right, so a lot of things in there, a lot of really great improvements that they've made. If you have any questions or you want to maybe try it out for yourself, you can get a software trial from Autodesk. You can get a 30-day trial. You can also reach out to the IMAGINiT sales team, and we can help you get that set up. If you want a demo of any other specific functionality of PowerMill, reach out to the IMAGINiT team, and we can set up a demo of that for you as well. And in that PowerMill Getting Started page from Autodesk, there's a lot of really good videos showing you some of the other capabilities of PowerMill when it comes to 3-axis and 5-axis machining. All right, so thanks for attending. We kept this one short just to get through the new features here. So if you have any other questions on either the new features or PowerMill in general, you can go ahead and